All right, so today we're looking at slope fields. Slope fields are a way to kind of approximate the solution to a differential equation. We're going to use it for all different types, but there are going to be a lot of differential equations that we can't solve yet. You'll be able to have more tools to be able to solve them when you get to Calc 2 or when you get to Calc 3 and differential equations specifically when you get to college. But for now, we're going to be looking at just general slope fields. We're not going to skip this one because it's a pretty easy one. So a slope field is formed by a grid, and we're going to draw a sketch of the slope at each individual point. We do this by plugging in the x and y to find it. So, for example, at the point 1, 1, so this is the point 1, comma 1, we plug in x and y to find the slope. This would be negative 1 over 1, which is negative 1. So we end up with a slope of negative 1. So we're going to draw to our best approximation a slope of negative 1. And just a short line segment there. And we're going to do that for every single point on the graph. So like this one is the point, this point is the point 0, 1. So we'll plug in 0 for x, 1 for y, that gives us a slope, or sorry, 1, 0. We'll plug in 1 for x, 0 for y, that gives us a slope of undefined, which is going to be a vertical line. Okay, and we're going to do this around the whole graph. So I'm going to pause the video, take a minute to sketch out all of it so you can see your answer, and then I'll come back. All right, so here's our completed slope field. If we look at this, you're probably wondering yourself, well, how does this make a solution to a differential equation? Well, if we follow along one point, so let's say we pick along this point right here, and follow the slopes that we're seeing, we can see an approximate for what this solution to the differential equation is going to be. So in this case, if we solve this differential equation, it'll give us the equation of a circle. All right? Now, one thing I will tell you to do, and the AP exam will tell you to do a lot of times, is not only graph the differential equation or the slope field, but also sketch the solution through, and then it will give you a point here. Okay, so at this point we'll do through 0, 1. And so we'll do that one we just drew. We're going to create a slope and match the slopes as best we can. All right. Now, there are a few rules about this that we're going to talk about in another problem, but for now, that's what we're looking at. So let's look at another one. So this one right here, I'm going to go ahead and pause the video. You pause it as well and draw your own slope field for this one, and then we'll come back in a second and look at what this one is. Actually, let's do this one instead. All right, so I'll pause the video. Be right back. All right, so this is a slope field I've made. Now, one thing to note is these slope fields are not going to be super exact. There are going to be a few that we are looking for exactly, like any slopes of 1, like this line right here, down the middle, that line right there. Any slopes of 1, any slopes of negative 1, like this diagonal right here. Any slopes of 0, like this one right here. And any slopes of undefined. You should have pretty exact. But once you start getting to slopes of 3, 4, 5, negative 3, negative 4, negative 5, we're not looking for anything super specific. Like this one right here, it's positive 2, negative 4, so that's a slope of 6. I'm not looking for you to exactly get a slope of 6. That's the closest we're going to get for that one. So we're going to leave that one as it is. All right, so there's our slope field. And now let's look at it through a point. Let's say we're looking at it through the point. So through, or sketch the solution through negative 1, negative 1. So that's this point right here. Now what they're going to look at on the AP exam is first, do you go through that point? Okay, that's an easy one, but that means that's where you should be starting. Second, does it have the correct slope? They're always going to pick one that has an easy slope to mimic. So in this case, I picked a point where the slope is 0. So we're going to go through this point, and we're going to make sure it has a slope of 0 right there at that point. Then it has to follow along the pattern to extend to the end of the graph. So let's start with this side. This should be getting steeper and steeper, extending to the end of the graph with an arrow. It should not go outside of the graph, but it should go all the way to the edge. The last thing they're going to look at is, does it cross any asymptotes? If we look, we see this right here, which seems almost perfectly straight. And then down here, it also seems to follow along that straight line on either side. So that means this represents an asymptote. So we're going to follow along that asymptote right there, and we're going to make sure we get close to it, but we never cross it. And we go to the end of the graph, and we stop at the end. We don't extend off the graph. This is a sketch of our solution through the point -1, -1. Okay, and this would be what gets you full credit. If you don't extend it to the end of the graph, you're going to lose points. If it doesn't follow along the curve or match the correct slope, you're going to lose points. If you cross an asymptote, you're going to lose points, and we will test you on that. Okay, so that's 2 practice problems. These take a lot to do, so I'm going to let y'all just work on the worksheet. Let me know if you have any questions. You'll have a great day.